Question 5 starts with a bond energy calculation. So we've got a reaction here, and we need to use this reaction and these values up here to do these next three questions. So the first question asks us to use the data in the tables to calculate the total amount of energy required to break all the bonds in the reactants. So our reactants are here, this molecule here, N2H4, and hydrogen peroxide, H2O2. So bonds that require breaking are, let's work through them logically, are NH bonds, and there are 1, 2, 3, 4 of them. Each one requires 391 kilojoules to break, times by 4. We also need to break a single nitrogen to nitrogen bond, and there's only one of those. So that requires 159 kilojoules per mole times 1. So we've done this molecule N2H4. Moving on to this hydrogen peroxide, we've got OH bonds 1, 2, 3, 4. So that would be 463 times 4. And finally, we've got 1, 2 oxygen to oxygen single bonds. So that would be 143 times by 2. Now we take all those values and add them together. Which gives us an answer of 3,861. So it's a similar process for the energy release when bonds are made. So we've got one nitrogen triple bond, which is here, which requires 945. That's just the one of them, kilojoules per mole. And we've got in total 8 oxygen to hydrogen bonds, 1, 2, 3, 4, 5, 6, 7, 8. So oxygen to hydrogen requires 463 kilojoules times by 8. Again, we use the sum of those two values. So the answer, the total energy released when all the bonds are made, is 4,649. Now to calculate the enthalpy change, so we need to take the energy required to break all bonds, 3,861, and take away the energy released when all the bonds are made, 4,649. And that gives us an answer of minus 788.